use this given information. Tangent of theta equals 1/2. Theta is between pi and 3 pi over 2, and we're asked to find the double angles of sine, cosine, and tangent. With the given information of tangent of theta, in my think out loud, I talked about the Pythagorean identity. Partner A, tell partner B the Pythagorean identity we're going to use. Eileen C, tell us the Pythagorean identity. Remember, this is another way of writing that Pythagorean identity. So what I'm going to do is just put in tangent. So now I have 1/2 squared plus 1 equals secant theta squared. Plus 1/2 squared. This 1 will turn into what? 4 over 4. So if I add those together, I get 5 over 4 equals secant of theta squared. To get rid of the power 2, I'm going to take the square root. So that's going to be plus or minus radical 5 over 2. Right? Square root of 5 and then square root of 4. And in quadrant 3, secant is? Secant is? Negative. Okay. How can I use secant now? We can use a reciprocal identity. Okay. Some students don't know which one to start with. Do I start with secant or do I start with cosine? Well, what are we trying to find? Cosine. Cosine of theta equals 1 over secant. Another way you can think about it is you can just, what letter is secant? X, Y, and R. If this is R over X, you can just flip it, can't you? Does that make sense? I'll do it the long way so you can see it. 1 divided by secant. Secant is negative. Secant is negative radical 5 over 2. And you're just changing the multiplication and then you're flipping. So that becomes negative 2 over radical 5. Now, I know what you're thinking. You're probably thinking the next step would be to what? Rationalize. But I just want to see what would happen if I don't. It's not harmful that I haven't rationalized here. So now I have cosine. Okay, talk to your partner. Now that I have cosine, which one of these and their formulas can I use? Ready, set, go. Gabriel. Now that I have cosine, which one can I use now? Sine 2 theta, cosine 2 theta, or tangent 2 theta? Echo? Correct. What's the formula you're going to use? Which of the three? Two cosine theta squared minus 1. So now what we're going to do is we're going to take this value of cosine and we're going to put it in here. So I'm going to put in negative 2 radical 5. Negative 2 over radical 5. And then we're just going to simplify this. Class, should I multiply by 2 or square root? Square root. Negative times a negative. 2 squared. And square root of 5 squared. Radical 25, which is just 5. How do you make it to a fraction? So now I have 8 over 5 minus, what does that become? 5 over 5. So my answer of cosine of 2 theta equals 3 over 5. Raise your hand if you got that. Good. Okay, question. We're trying to get these double angles for sine, cosine, and tangent. We have cosine. Which one can we do next? Okay, if we do sine, partner A tell partner B the formula. Ready, set, go. Genesis, what's the formula? Okay, class, which one do we have? We have cosine, but what are we missing? Sine. Take 40 seconds with people around you. I want you to find sine of theta. Ready, set, go. Jason, what identity did you use to find sine? Tell me the Pythagorean identity. Okay. So we already have cosine. Cosine is negative. Kind of weird, but we abbreviated. And then we also wrote, we didn't rationalize, right? Sine squared plus negative 2 over radical 5 squared equals 1. Class, negative 2 squared. And radical 5 squared. And this one's going to turn into 5 over 5. So if we subtract 4 over 5, sine squared equals 1 over 5. Take the square root, it's plus or minus. Sine equals square root of 1 is 1. Square root of 5 is radical 5. And it'll be positive or negative? Why? Because in quadrant 3, all students take calculus. Quadrant 3, it should be negative. Right? Okay, now that I have sine, we can use that to find the double angle identity for sine of 2 theta. So there's my yellow. Whoops, we already used yellow, huh? Let's try a different color. Purple. Purple. So now I have up here 2 times negative 1 over radical 5. And the green is negative 2 over radical 5. Do you see the advantage of me not rationalizing? Do you guys see it? Yeah. Is that nice? Can you imagine if you rationalize? Okay. Try this one now. Negative times negative. So if I multiply the numerators, I'll get 2 over radical 5 times radical 5 is 5. So sine of 2 theta is just 2/5. Okay, let's talk about tangent. There's a couple ways you can find tangent. You can use the double angle identity for tangent. You can use 2 times tangent of theta over 1 minus tangent theta squared. Raise your hand if you use that. Question. Four-fifths. You are correct. Thank you, Jocelyn. 4/5. You sidetracked me. Okay. No, that's right. Tangent of 2 theta, you can use this, or we can also use what? You can use a variation of the quotient identity, and it works. You can use tangent of 2 theta equals sine of 2 theta over cosine of 2 theta. I'm going to use this one. The reason why is that I don't want to find tangent using the quotient identity and then have to put it back into this formula. Does that make sense? I can just use these two. So I'm going to use sine, which is 4/5, divided by 3/5. And then what happens here? Multiplication, and then there. Flip it. So I get 4/5 times 5/3. What happens there? 5's cancel, and then tangent of 2 theta equals 4/3. So in some ways, kind of difficult where we have to use our fundamental identities in order to help us find the double angle.